Hi, 7th graders. We are on lesson 210, converting between scientific notation and standard form, and it starts on page 130 in your textbook if you want to follow along. Scientific notation is a compact way of writing very large and very small numbers. It's just an easier way of writing those numbers in a different form. So if you look at this number or this form in the box right here, this is an example of scientific notation, 6.3 times 10 to the fourth. So if you look, the number being multiplied by our exponent of 10 is always a number greater than or equal to 1 but less than 10. So it has to be a number between 1 and 10. It can't be 10, but it can be 1. Okay? We're always using our multiplication sign, and it's always being multiplied by a power of 10. Whether our power is positive or negative, it doesn't have to be a positive number, but it's always a power of 10. So the most important thing to know is this number is a number between 1 and 10. So if we want to convert between scientific notation and standard form, well, we first look at our exponent, and if the exponent is positive, we move the decimal to the right. If the exponent is negative, we move it to the left. So here we're looking at 6.34 times 10 to the fifth. Our exponent is positive because 5 is our exponent and 5 is positive. So I move my decimal to the right, and I'm actually going to move it that many places. So I'm going to rewrite 6.34, and I want to change colors. And I'm going to move it 5 to the right. So I have 1, 2, 3, 4, 5, and this is where my new decimal is going to be. And then I fill in these little humps that I made with the zeros. So then I go back and I recheck. If my decimal is here, then I know it goes 1, 2, 3, 4, 5, because the easiest mistake is to add too many zeros or not enough. So now my new number is, and I can put in my commas, 634,000. We don't have to keep our decimal because we know that if we write a number like this, we don't need our decimal at the end of it. So 634,000 is the same as 6.34 times 10 to the fifth. If we have 6.34 times 10 to the negative fifth, our exponent is negative, so we're going to move our decimal to the left. So I'm going to rewrite 6.34. This time I'm going to move it to the left 5. So I go 1, 2, 3, 4, 5. Here's my new decimal. And then I plug in zeros. Now I have to make sure that I do it nice and neat, which I know isn't very nice and neat here. But when you're doing it, you want to make sure you leave enough room so you know how many zeros you're supposed to add in into your little divots that you go in here. So now I look and I see 6.34 times 10 to the negative fifth is the same as 0.0000634. And to double check, I can see my decimal was here. I go 1, 2, 3, 4, 5. So this form right here is scientific notation. This form right here is standard form. So that is the difference between scientific notation and standard form. Okay, so I want you to try these 3 really fast in your notebook. I'll leave it up here so you can see. So if we have 7.42, I'm going to move this over 1, 2, 3, 4, 5. So my answer is going to be 742,000. 6.1 times 10 to the negative 2, so I know I have to go to the left, so 1, 2. So it's going to be 0.061. 3.714 times 10 squared, you go 1, 2. So our answer is actually going to be 371.4. All right, if we want to change from standard form to scientific notation, this is a little bit more confusing. What we need to do, remember, if I go back to this really quick scientific notation, we always have to have a number between 1 and 10. So looking here, if I look at my number 4,354,000, I first need to look at my step 1. It says move decimal to the right of the first non-zero number. Okay, so the first non-zero number in this one is 4. So that means I somehow need to get my decimal right to the right of 4, so right here. Okay, and 4 point something is going to be in between 1 and 10, so that's why we're going to that number. So our decimal right now is right here. We just don't have it on there because we don't need it. So I'm going to count 1, 2, 3, 4, 5, 6. It takes me 6 moves to get the decimal right to after the 4. And now I'm going to rewrite it. 4.354. And I'm going to write it with all of my non-zero numbers, but I don't include the other zeros. Okay, and then I go back, because you probably forgot, and so did I, and I count how many times or how many places I moved my decimal. So 1, 2, 3, 4, 5, 6. So I write it as 4.354 times 10. And if I moved it to the left, then the exponent is positive. So times 10 to the 6th. And then if you think in your head, okay, this is a times. If you think in your head, well, it has to be positive because you want to go 6 to the right. So 1, 2, 3, 4, 5, 6. You'll add the 3 zeros and you end up with that. Okay? So this is where it's a little bit opposite in your head because we're moving to the left, but our exponent is going to be positive. Remember back here, we're moving, if it's positive, we're moving to the right. So it's backwards here. Okay? So here, move decimal to the right of the first non-zero number. Well, our first non-zero number, again, is 4. Okay? So now I want to figure out how many places do I need to move to get to here. Well, the decimal is over here, so this time I'm going this way. 1, 2, 3, 4, 5, 6. Okay? And again, I write 4.354. I moved my decimal to the right. I was going to the right, so my exponent is negative. So it's 10 to the negative 6, because I moved 1, 2, 3, 4, 5, 6. Okay, so see how we have totally different numbers, one really big number, one really small number. Their scientific notation is very, very, very similar, except this negative changes the whole thing. Okay, that tells me it's a really small number. This positive number tells me it's a really big number. Okay, let's do another one together. So if we have 14,140,000, my decimal is right here at the end. Okay, so I know that I want to get all the way over to my 1, right after my 1. not 14, right after my 1, because that's my first non-zero number, and it's the number that is between 1 and 10. If I go to 14, that's too big, that's greater than 10. So then I count 1, 2, 3, 4, 5, 6, 7. So I write 1.414 times 10 to the 7th. The greatest mistake I see is that people are being really lazy or sloppy when they're counting their decimals and then they miscount. So make sure you're being really careful at counting every time you go in between numbers. That's how I count. Right in between, it tells me all the different places that the decimal is moving. Okay? Here we have 0.00876. So 8 is my number between 1 and 10. So we can actually just write that so I know that it's going to be 8.76 times 10, and then we go 1, 2, 3. I move to the right, so my exponent is negative, to the negative 3. Do this last one on your own, which is fairly simple. All I'm moving is 1 to the right. So 1.14 times 10 to the negative 1. Okay? Standard form to scientific notation is a little bit more confusing than scientific notation to standard form. These are important notes to have written down, so you may want to take time to write those down. You can also look in your book on page 130 and 131. It will explain it a little bit more and a little bit better. Okay? And then don't forget to take your 210 NICU quiz. Have a good night, and I'll see you tomorrow.